In this lesson, moving forward, I'm going to talk about the DHCP server, which is the Dynamic Host Configuration Protocol. So the DHCP is a client-server protocol, and the main function of DHCP is that it enables client computers, whether it's your laptop, your personal computer on the network, for instance, to obtain IP addresses from the server automatically. So for instance, you come to work, open up your machine or turn on your machine, for instance, and as soon as you turn on, you will get an IP address assigned from the server. The IP address might include the following: the IP addresses. You may also get assigned a subnet mask, gateway addresses, DNS server address, and other options as well. The DHCP server service provides two benefits. One is the reliable IP address configuration, and the other is to reduce network administration. Because having static IP addresses assigned to all computers on the network can become cumbersome at times. What if you had 5,000 computers on the network? So it's easier to just have the server assign IP addresses once the client computer is switched on. Before the DHCP server can actually start leasing IP address to client computers, the following steps must be performed. We need to install the DHCP service on the server, configure the IP scope or the range of IP addresses, activate the scope, authorize the server, and then configure other options if required. So once again, the basic idea, the concept of DHCP server is that you define a pool of IP addresses based on your own subnet, and then server would automatically start leasing out IP addresses to different computers. The four-step process known as DORA is used by DHCP. So the first is discovery. The client sends a broadcast to the network to find a DHCP server. So as soon as you turn your computer on, it's going to go out there and seek a DHCP server because it does not have a static IP address assigned to it. The second step is the offer. So the DHCP server sends the offering, a unicast offering of an IP address to the client. The third step is the request. The client then broadcasts to all servers that it has accepted the offer. So now everyone on the network knows that a certain IP address has been assigned to this computer so that it cannot be duplicated. So once the IP address is assigned, recall that IP addresses are unique. They cannot be duplicated or assigned to any other computer on the network. The fourth step is the acknowledge. The DHCP server sends a final unicast to the client computer that includes the IP information the client will use. So now the server completes this process. The DHCP service utilizes ports 67 and 68 to do this. The real motivation for using DHCP, for instance, the configuration parameters for network hosts, the IP addresses required, the router address, and the subnet mask. Before DHCP, there was manual assignment, like I mentioned earlier, or use boot P. So either way, instead of assigning static IP address, static subnet mask going to each node, what if you have a network that once again has over 5,000 computers? It takes a long time to do this, right? So that's one of the motivation for using DHCP, is to reduce the work. Here's the structure, just a preliminary structure of a network. So you may have DHCP clients, for instance, the 3 client computers. You have the DHCP server, and its job is to lease out IP addresses as soon as the clients are switched on, and of course to the router. And then once the IP addresses are assigned to the computer can navigate through the router to the internet, for example. So the port numbers again are 67 or 68 that DHCP server uses, and it uses the UDP. So in this lesson, just briefly wanted to demonstrate and actually talk about what DHCP server is, the main function of the DHCP server, and how clients obtain their IP addresses. So I hope this helps. let's move to the next lesson.